Hi there everybody, this is lesson 3.2.4. We're going to learn a new way to show that triangles are similar in today's video. So I'm going to kind of investigate that a little bit. So far we do know there's two ways to show triangles are similar. There's side-side-side similarity and angle-angle similarity. So if all three pairs of sides give the same ratio, they're similar, the triangles are similar. Or if you have two pairs of angles that are equal, then the triangles are similar also. Now, you might be saying as you're doing these flowcharts that using side-side-side is a lot of work. You might be thinking, I got to check three pairs of ratios. Sometimes that requires using a calculator because they don't reduce nicely. It's just a lot of work to use side-side-side similarity. So I wonder if side-side works. I wonder if I can have two pairs of sides instead of three, just two pairs of sides to give the same ratio, if that gives me triangles that are similar. Let's investigate that. So here we have two triangles. Let me get it so you can see it. There we go. We have two triangles. Sorry, this purple side of this triangle divided by this purple side gives us 1.5. Also, this red side divided by this red side also gives you 1.5. So here we have two triangles where two of the side ratios are the same, and that's all we know. Maybe the third side ratio is the same, maybe it's not. We don't know that. The question is, do these triangles have to be similar? Well, let's take a look at these other measurements. If we get equal angles here, then we know we have some similar triangles. Oh look, 22, 108, 49, 76, 60, and 44. None of those angles are the same. So those triangles, even though we have two pairs of sides that give the same ratio, in this case it's 1.5, those triangles aren't similar because the angles aren't the same. Let's move this thing around. I mean, maybe oh, still not the same. Look at that. Still not the same, still not the same. Those angles still aren't the same. Let's try another triangle. So there's another triangle. Again, we've got purple over purple is 1.5. This red side over this red side is 1.5. So two side ratios that are the same. Do these triangles have to be similar? Well, as you can already see, these angles aren't the same. We can move this thing all over the place, and those angles aren't the same. So those triangles can't be similar. Let's look at another triangle. Okay. So again, here we have this length of that purple side divided by that purple side gives you 1.5. The red side divided by the red side is also 1.5, so two side ratios that are the same. Are those triangles similar? Well, no, they're not, because none of these angles are the same. So let's go back to the question that I had here. Does side-side similarity work? The answer is no. You have to have all three pairs of sides giving the same ratio. Only two pairs of sides giving the same ratio does not work. What if the angle in between those sides was the same? That would be side angle side, because we would have an angle that's equal between the two side ratios that were the same. I wonder if that works. Well, let's take a look. So let's go back to the original case here. So here we have two pairs of sides. 6 over 4 is 1.5. 7.5 over 5 is 1.5. So two pairs of sides giving us the same ratio. Let's make these green angles the same. I'm going to drag this so that this angle is 22. They kind of look more similar. Let's look at the rest of these measurements and see what happens. So we got 108 and 49. Uh-oh, we got 109 and 49. What in the world happened? I think that should be, it's off just by a hair. Those angles should be the same. And trust me on that, they should. That's weird I think it's just a deal with or a problem with the resolution here. Those angles should be exactly the same. Let's check another pair of triangles. So here we have a couple of triangles. The purple over the purple is 1.5. That's 3 over 2. 5.2 over 3.5 is also 1.5. So we got two side ratios that are the same. Let's make these angles the same and then see if the triangles are similar. So we're going to make this one 29. There are the angle measures, and there are the 122 and 29, 122 and 29. Look at there. Those two triangles are the same, are similar. So it looks like side angle side might work. Let's try one more triangle. Let's try one more case here. So here again we've got two pairs of sides given the same ratio. Let's change this angle so that so A and A prime are the same. Now they're both 90. They kind of look like they're similar. And let's check. Look at there, 53 and 37, 53 and 37. They are the same. So does side angle side work? If the two side ratios are the same and the angles between those sides are also the same, it looks like those triangles have to be similar. So side angle side does work. Yes, it does. Well, what other things could we check? I mean, we've checked side, we've checked side angle side similarity. We figured out whether they work. What else could we look at here? Well, let's list the ones we know that work. We know that side similarity works. We know that angle similarity works. We know that side angle side similarity works. All these work. These are good ones. These work for showing that triangles are similar. I wonder if there's anything else. We already saw that side doesn't work. What about how about angle side? Angle side angle. Side angle. Gosh, what else could we? How about angle side? How about angle side angle? I mean, there's lots of these that we could do. But let's take a look at these a little bit closer. If we have angle side, we have two triangles where two pairs of angles that are the same, and then we got a side ratio. Nothing to compare it to, but we got one side ratio. Well, do we even need this side ratio? Didn't we already say that if two pairs of angles are the same, that we have similar triangles? I mean, that's what this means. So looking at a side ratio is actually something you don't need to do. So this isn't one that we would use. And the same thing goes for this one. Here we've got two pairs of angles that are the same, and a side in between the angles that we have some ratio for. But checking this side ratio is information that we don't need if we already know that the two pairs of angles are the same. We know that's right because that's angle. So this actually isn't one that we'll check either. And for the same reasoning, we would never use these either. If you have two pairs of angles that are the same, you don't need to check any sides, so this isn't one we'll use. Here we've got all three pairs of angles being the same. That's not one we'll use either. That's way more information than you need to check. You only need two pairs of angles. The only one left is this side angle one. So I wonder I wonder if side-side angle works. For showing that triangles are similar. Let's go back to our sketch here. Here we go. So this is the same kind of situation as before. This purple side divided by that purple side, 8 divided by 5.3 is 1.5, and 10 divided by 6.7 is 1.5. That's these red sides. But this time we have an angle that isn't in between them. If the angle was in between those, it would be side, angle, side. And we know that works. But this one is side, side, angle because the angle isn't between the sides. So the question is, does this one work? Well, let's make the angles the same. Now, this point right here, in order for this to make a triangle, that point has to be right there. And those two triangles kind of look similar. They look like they're similar triangles. Let's check these measurements here to see if the angles are the same. Oh, look there, and they are. We have two 22-degree angles. We have 208-degree angles in those triangles. So it kind of looks like it works. However, there's actually another triangle that we can have so that those side ratios are the same and this angle is the same. And it's this triangle. And those don't look similar anymore. And we can look at these angle measurements to prove it. See here, this one's 22, and now the corresponding angle is 59. They're not the same anymore. This one's 72, and this one's 108. Those aren't the same anymore. So sometimes side-side angle works, and sometimes it doesn't. And with these flowcharts and in math in general, we're really interested in methods for doing stuff that always work. Not sometimes, because then we got to determine what kinds of situations we can use side-side angle in. And that's just extra work that we don't need to do. So we are going to say that side-side angle does not work. In reality, it does sometimes, but we don't really know a way to determine when it works and when it doesn't. So we're just going to say that side-side angle does not work for showing triangles are similar. And there's an easy way to remember that. Side-side angle spells a bad word backwards. So if you're ever thinking about what to use, these are the three that work. This one doesn't work because it's a bad word backwards. So don't use the bad word backwards. Use side-side-side similarity, angle-angle similarity, or side-angle-side similarity. All right, that's it for today. Hope you have a great day. We'll see you tomorrow. Bye.